Our study of electric circuits has involved direct current so far, but it's possible that you haven't fully comprehended what it entails. We will now take a closer look at direct current, which is commonly known as DC. Direct current is simply electricity flowing in a single direction. It is also used to refer to a voltage source that has constant polarity. It is the kind of current you get from the batteries in your devices. That may not sound like a big deal to you. In fact, you may ask, are currents not supposed to flow in a single direction? Not necessarily. Currents can actually periodically reverse the direction of their flow in a circuit. This kind of current is called alternating current, or simply AC. Alternating current is also used to refer to a voltage source that is switching its polarity back and forth. This kind of electricity is the type you likely have access to from the power socket at home or from a rotary electromechanical generator. DC is the kind of electricity you get from a battery. The familiar battery symbol is used to represent the DC voltage source in circuits, while a circle with a wavy line inside it is used to represent an AC voltage source. AC is usually represented by a sine wave for most electric power circuits, with the magnitude of the current or voltage on the vertical axis and time on the horizontal axis. The positive half of a cycle represents the positive direction of the current, and the lower part represents the negative part of the current. The general equation of a sine wave for voltage is given by V as a function of time t equal to V naught sine open bracket 2 pi ft plus phi, then close bracket. The general equation for current is similar, with V replaced with I. We'll come back to these equations and what all of these terms mean in subsequent lessons. AC can also be represented by square waves and triangle waves. Square waves are usually seen in digital and switching electronics to test their operation, while triangle waves are usually found in sound synthesis, that is, the artificial production of sounds. Now, you may ask why anyone would bother with such a weird thing as an alternating current, since our electric torches and phones work just fine without them. Well, AC allows us to build electric generators, motors, and power distribution systems that are far more efficient than DC. One of the reasons for this is that AC generators and AC motors are usually simpler to build than DC generators and DC motors. This is why the power supply to your house from the grid is most likely AC power. Transformers only function with AC and not DC, which is another reason why AC is more frequently used for large-scale electric power delivery. This is a very big deal because it is easier to transmit electric power at high voltages. Check out our lesson on the transformer to learn more about this. In summary, we've learned about alternating current in this lesson. We've seen some of its applications, and we've seen why it is used to provide electricity to our homes from the power grid. Keep learning.